Hello students, welcome back to section 11.1 about the sequences. Today we will discuss two important concepts. The first one is the concept of increasing and decreasing, and the second concept is the concept of bounded and unbounded. So let me start with increasing and decreasing. Well, increasing sequence, it's like an increasing function. It means if you have something like this, and the numbers are getting higher and higher and higher, so every term is bigger than the previous one or larger. This is, we call it increasing sequence. Now, if the opposite is going on, for example, the numbers are getting smaller and smaller and smaller and smaller, we call it decreasing. So the number like 1/2, 1/4, 1/8, 1/16, look at those numbers are getting less and less. This is, we call it an example of decreasing sequence. So let me just write down here for you, what do we mean by increasing? Increasing sequence, it means if you take an, any term, and you compare it with the next one, the one after that, it should be getting larger. On the opposite is we have the decreasing sequence. This means if you take an and the one after that, it should be getting smaller. So just be careful of our sign here. This one here and this one here. Just be careful the direction. So an is getting larger or smaller. This is decreasing and increasing. Now for practical purposes, how are we going to check if something increasing or decreasing? As we can use the derivative. So you have your function f of x from an, and then if the derivative is positive, this is increasing, and if derivative is negative, this is decreasing. So just put this in mind, that this is maybe the straightforward method because we know how to find derivative, and finding derivative is very easy and simple. So let's do it with this question. I have an as n plus 1/n. So if I write my function, it will be the same as the sequence, but I just change n into x because we get used to having x. And now I find the derivative. And the derivative will be 1 minus 1/x squared. Now, is this positive or negative? I don't know. I need just to play with it. So just have a common denominator. This give me x squared minus 1 over x squared. And this is positive. Why this is positive? Because the one on the top, remember x is very large number. We can think about x can be 1, 2, 3, 5, 7, 10. So this will be positive. Of course, anything square is positive. Positive over positive is just positive. Okay, so that's it. And this function is increasing. Now let me go to find the second concept, which we call it bounded or unbounded. Now what is bounded? Now you have a sequence, and you can see the number in the sequence, they are less than a number, less than a certain number. For example, if you look at this sequence, 1/2, 1/4, 1/16, and so on. Here you can see that those numbers are always less than 1. So we call it bounded. And of course greater than 0. So those are always like between 1 and 0. Any number of these is between 1 and 0. And in this case, we call it bounded because we have bound. It cannot go more than 1, it cannot go less than 0, so it is bounded, something really, really bounded. Now, if we look at this one, 3, 5, 7, 9, 11, 13, and so on, this is unbounded because you cannot say it is between such and such. It goes to infinity. It has no limit. It just keep going. So here we need to be just careful with this one. And one of the things that we might be able to find bounded and unbounded is by writing few terms from the sequence and see what we will get. So in our example here, my sequence is an n plus 1 over n. Now if we start writing terms, the first one will be 2. The second one, we substitute n equal to 2. This will be 2 plus half, so it is 2.5. The third one will be 3 plus 1 over 3, so it is, I think, 3. The next one will be 4.25. The next one will be 5.5, 5.2. The next one will be 6.66, and so on. Now this is clearly unbounded because the number are just getting higher. We get 1, 2, 3, 4, 5, so the next one will be getting even higher and higher. And how do I know it is really unbounded? Because of this one in here. You see, whenever you put n, if you put n large, the whole thing will be large, so it will never stop anywhere soon. So this is unbounded sequence. The next example is this one. This is, we have seen it. This is the alternating sequence here. Now, for this one, let me write the first few terms because maybe we can even tell exactly what it is. So I want to find, I will start with A0, A1, A2, A3, A4, A5, maybe with A6, and that's it. Now A0 is just 3, A1 is 1, A2, 3, A3, 1, A4, 3, A5, 1, A6, 3, and so on. Now we can say that this is neither increasing or decreasing, because it's not getting all the way larger or smaller. It gets 3 and then get 1, 3 and 1, large, small. So it is not increasing and decreasing, and it is bounded because everything here is between two numbers. I don't see any other number that can happen here. So here between 1 and 3. And that's how we find it's increasing or decreasing. Thank you for watching.